Yo, what's up, everyone? First, check out what I got. I got a printed worksheet, and I'm stoked about it. It just makes me feel a lot more comfortable seeing a worksheet I made. So I'm really stoked about this. I got my printer up and running, and from now on, we can look at this the same way. So if you have a printer, I highly recommend printing it if you can. But if not, separate sheet of paper also super works. We have a good lesson today. I'm pretty excited about it, and we're making great headway on the unit. I think we'll finish the unit next week and go from there. But we're going to start by talking about box plots, which we've done a little bit before, but we're going to extend on them and then teach another type of graph, the stem plot. So we're going to do two questions, and I'll start with the first one. And it says, Kibi is competitive with the principal at the ends about everything. He wants to make sure that PV students have better internet connection than the rival school. So he has both schools ask 50 random students to take an internet speed test. The results were measured in ping and compiled into the following two box plots, the first being PV and the second Dianza. So first, there are a lot of word problems in this class, and whenever you're reading a word problem, you just kind of want to get in the head of it and figure out what it's talking about. And here, you might not know a lot about internet, but you can measure your internet based on its ping. And they took 50 students from each school randomly and had them measure their internet. So what you need to think here is we're starting with the box plot and not the data set. Okay, so this box plot represents 50 students, okay, where the median ping value is 10, okay? The fastest student, because the smaller the better actually, is like at 2, and the slowest internet is at 50. Okay, so think that this represents some sort of data set that's just not shown, okay? So we're gonna try to figure out how much we can do without the data set and just with the box plot. That's kind of today's gist. So first it just says to identify the 5-number summary for each distribution to compare the center and spread. So remember, anytime we're talking about a distribution, center and shape and spread are the most important parts. And here, as we were kind of talking about before, we don't have the full data set, but we have 5 numbers for each. Okay, so remember, a box plot gives us the minimum, the maximum, Q1 and Q3. Okay? Maybe I'm off the screen. So for this, all we have to do here is see that this is the smallest value. So the minimum for PV was 2, and for Dianza the minimum was 5. So if we were comparing these distributions, we're off to a good start. Our top student has better internet connection. Okay, but we can keep going, right? So that's the minimum, but Q1 is 5 for PV. The median is 10, Q3 is 20, and the max is 50. Okay, and I just went down, and I'll do the same thing here. And Q1 and Q3, are the most confusing part, and that's a lot of what today is all about, really thinking about what a box plot does. Okay, so here we have our 5-number summaries, and we can talk about center and spread. Okay, so we're trying to compare. And as far as center goes, if we wanted to compare them, we can see that PV has a greater median than DA at 10 being greater, or small, sorry, it is a smaller one, but smaller is better. So if we're comparing these, and my handwriting kind of sucks, but it's fine. Just from looking at them, PV has a smaller median, okay? And that's pretty apparent, that's pretty visual. And that is a measure of center. So if it ever asks to compare the center, we don't know anything about the mean. There's no chance, but we know about the median. Then as far as spread, think that we can measure the range and the IQR. Okay, just because we have the best score doesn't mean anything if we have a huge range where some students are doing really bad. So a small range for spread would indicate that a lot of students have close to and good internet. So as far as the range is going to be 48 for PV and 45 for De Anza, so we can say PV has a larger range. And I know it seems even stupid, but we can just say because 48 is greater than 45. And then we can do the same thing for the IQR. Okay, and the IQR measures the middle 50% of students. Okay, and if I haven't explained this that well, think that this box represents the average student, right? The middle 50% of students are like the most average students. These students are doing way better than average because they have faster internet. These students are doing worse. But these are like your average students. Okay, so we want our average students to all have good and close internet. If this range is really big, that means that our data is spreading out a lot too. So as far as the IQR, we know that the middle 50% of students for PV are within 15 points. And the same thing can be said for De Anza. They both have the same IQR. Okay, so that's how I'd answer this question. And all of that, arguably, you could say is review. But here's the best part of this. And it says to estimate the shape of the distribution using the box plots. And I'm going to write in the rest of them to create a sketch. Okay, so this is my favorite part of the lesson. And here's what I want you to think. We're going to really look at this box plot and try to figure out shape. So first, what we need to think is the shape of the distribution is where's all the data. Okay, so very basically, if all the data is close to the middle, that's the shape. If all the data is on one side, the right side, that's the shape. So we're going to make a sketch that's a little bigger than this, but we're going to see, can we see what the histogram would look like for this box plot just based on the box plot? Okay, so that's the premise. And what I want you to think here is that the box plot splits up our data set into 4 quartiles that all have the same amount of data. Okay, so remember that when you find your 5-number summary, you are crossing out data points. Okay? So we'll start with just the median. Okay? And we know that the smallest value was 2 and the median was 10. And that means that 50% of our data is here. Okay? So half of the data points are in between 2 and 10. So they're all scrunched up really close together here. The second half of students are in between 10 and 50. Okay, so think that half of the data set, think that this represents numbers, right? So you could think it's going to be like 2, 2, 3, 5, etc. Think that you're crossing it out, but the data here is much more spread out, right? So there's a 10, then maybe a 15, then a 20, then a 25. These data points are much more spread out on the right side because this distance is bigger. And hopefully you guys think this is cool. So if I'm estimating the shape, think and for all of these I want you to make a little sketch, okay? That this side of the data set is much more condensed, meaning there's more data here, and then it's spread on this side. So the sketch is going to look similar to this, and it's skewed right. Because if we were to estimate here, think that this is 2, this is 10, and this is 50. A lot of data points are here, and an equal amount are spread out this way. Okay? So you can predict the shape of a box plot by imagining where the data is. And here you can even use it with these. So we'll do that for the second one. Hopefully that makes sense to everyone. So the shape here is PV is skewed right. Now we'll do the same thing for D and O. And we'll look at go a little closer too. So now that you understand that, think that every section of your graph is going to have a distance, right? So here to here is 15. Here to here is 5. So the smaller the distance between one part of your 5-number summary to the next, the more condensed the data is in that part. So here, 5 to 15 is spread. Crap. 20 to 25 is really close together. 25 to 35, that's also closer than this. So there's more data here than here or here, okay? So wherever you have the smallest section is where the most data is. So here, a lot of the data is close to the center because this is the most. Then to the right of the center is a good amount of data, and then both the sides have less. So this is going to be roughly symmetrical, okay? And I haven't talked enough about symmetry. So think not a lot of data, a lot of data, a little bit less data on both sides, okay? And we could say this is roughly symmetrical. And today is all about expanding shape. So all we've really talked about so far is skewed versus symmetrical. And sometimes it's not perfect, okay? So you really want to evaluate, is one side much different than the other? And if there's bumps, that's fine. Okay, so it doesn't have to be perfectly symmetrical. This graph has more data from 20 to 25 than 25 to 35, but it's roughly symmetrical because the sides are bigger. Okay, so last time I actually forgot to give you like a little graphic. I'm going to give you a graphic of all the shapes because symmetry versus skewness is the most important part, but it's not the only part. So that is that. I think that's really cool. Hopefully you guys enjoyed that. And now we're going to talk about a second type of graph, the stem plot. And for a lot of this stuff, honestly, you may have done this before or seen this before in like even in elementary school. I usually assume you've at least seen it. But the stem plot is kind of the perfect graph. And it doesn't always work. But what I want you to consider, and I always draw little side examples, okay? That's kind of one of my teaching methods. They're not always pretty, but it's always about the logic. But think like if you have a histogram, we don't know the exact data points, right? That's a problem with the histogram, that's a problem with the box plot. And you don't know because you just know that there's so many in a bar from like 0 to 5, for example. So what a stem plot does is it's going to show us the shape of graphs, like a histogram, but also what the exact data points are. So all we're going to talk about is quiz scores. That's kind of my go-to example because it's really easy to understand. But this is second period, this is third period. Think about this is the first quiz, and these are the scores. And we're trying to compare them. Okay, so we have two data sets, and we want to put them both on the same graph. So that's another complication with a histogram, right? You can make two histograms, and we do that, and compare them. But a back-to-back stem plot puts two graphs on the exact same, sorry, two data sets on the exact same graph. So here's how we're going to do it. And we're going to do them one at a time. So all a stem plot does is it only works if you have numbers 0 to 100 or 0 to 500. And you put the first number of the number on the left side in what's called the stem, and the second part of the number in what's called the leaf. And 0 is the most confusing. So it's always tough to start with 0. But think that there's 3 zeros, and the 10th place for 0 is 0. And then each circle this way represents another 0. So this is 3 data points, all in the 0 range. The next thing that happens is we go to the ones, right? When you go to the ones, there's exactly one data point and it's 7. So that data point here is 17. So the stems aren't data points. The stems are like what all the numbers have in common, and the leaf is going to be the data point itself. So you can't skip because we want it to be consistent and have each interval be the same with a histogram. But we can do it all the way till we get to 100. So let me write out these. And I'm going to be narrowly enough space. And hopefully a lot of you already catch my drift. But there's no 20s, there's no 30s, but there's 3 40s. So we're going to put them here, and this will be 1 1 7. And I'm going to keep doing it, but as you draw it, notice if you can see the shape of what's going on. So I'm going to do this entire data set and put it here. So I'll be back in a sec. Okay, so that's my stem plot, and it's not the prettiest, but think that for B, it's going to ask us to compare the shape of the distributions. And if you have a stem plot, think that if you flip it over horizontally or vertically, 90 degrees, whatever you want to call it, this is a histogram, right? These are the zeros, these are the ones. So we can see where all the data is, right? Most students were getting a 70 or an 80. And I do appreciate you because this is roughly what happened with the real quizzes, and people were really honest, so I appreciate you for that. So most students were around 70 to 80. Most students were around 70 or 80, but this shape here is kind of indistinguishable, right? And if we wanted to make a sketch, think that this is what it would look like. Okay, so you can actually sketch on top, and that's what the shape would be. And that doesn't resemble anything that we've talked about recently. That doesn't resemble skewness or symmetry, right? If you had to guess, it's probably skewed to the left because there's less data over here than scrunched over here. But this doesn't really represent symmetry or skewness. Okay, so if you're ever asked to do a shape of something random like this, I want you to notice what's called the clusters and the gaps, and they're exactly what they sound like. So this is a gap, and this is a cluster, and if this was your shape, you could say it's neither skewed nor symmetrical. But there's a gap at 2 and 3 and a cluster at 7 and 8. Okay? So again, sometimes, if you were to find the mean and the median, you could actually figure out if it's skewed one direction, but sometimes the skewness is indistinguishable. So for second period here, if we're going to compare the shapes, and we're going to go back to third, but for second period, we can say it is neither symmetrical or skewed. But has gaps at 2 and let me write it. Okay, so this is really the shape lesson, and I'm saying it's neither symmetrical or skewed, which are the most important, but has a gap at 20 to 30 and a cluster at 70 to 80. So if you're ever asked to do the shape, you talk about both these things if you can. The symmetry versus skewness, and also gaps and clusters. Okay, so this always will get you something. You can always say something about your data set if asked, okay? Because sometimes in real life, this is really common, really random data sets. So that's second period, but how are we gonna compare third period? And I love this, so get excited. This is a great lesson overall. But we're just going to put this data set over here. So this was our first side, but we can put it back to back with second period. So what I mean by that is we have 1 0, an 11 and a 7, and always start closer to here. So think you're really going in reverse. So 1 and then 7. The numbers get big as you go farther away from the stem. No 2s, 2 3s, and I'm going to keep doing it like that. Okay, so that's our second one, and I'm going to erase this for now. so that we can kind of see the full thing. So this is really useful because you can see what's happening in both of them right next to each other. And the shape here is kind of similar to this, right? And the reason is a lot of the data is close to the top with less data close to the bottom. So if I wanted to describe the shape though, it actually looks more skewed than the other, right? It's kind of going down. So while the other one was kind of jumbled, this one is definitely skewed. Most of the data is here, what appears to be the left side, and this is the right. Now here's going to be our complication. Let's just ignore the shape that was here, and let's pretend that it was skewed left, okay? We know this is skewed left because the less data always is the skewed side. So if all the data is on the right side, think that the left side screwed it up because there's data there. So this is skewed left, okay? But if I were to look at now my left side, this appears skewed right, where most of the data is on the left. But both of them are kind of representing the same thing. Do you see what I'm saying? Both of them have a lot of data on the high numbers and not that much data on the low numbers. So, and this, I love this, hopefully this makes sense to you, but when you have a back-to-back stem plot, this left side is going to be flipped, okay? Because this is not what's actually happening. What's actually happening on the right side is there's not a lot of data from zero. Crap. Sometimes I get excited and then I do even worse. But think, okay, these are the zeros, these are the 10s, the 20s, the 30s. On the right side of my graph, there's not a lot of data here, but a lot of students over here. So in a back-to-back stem and leaf plot, the right side of your graph, so there's two data sets, the right side is going to show us the accurate graph because it's going from 0 to 10. But on the left side, think that your axis is going from 10 to 0. And that's not how a graph works. You always go from 0 to 10. So if it appears skewed right when you sketch it this way, it's actually skewed left. So let me write that down. So for third period, the shape here is actually skewed left, even though it looks right, and there's a gap in the 20 range. So that's all of that. Really, really excellent job today, and we're crushing it so far. I'm kind of in a groove. I felt really good about this lesson, so I appreciate you for watching.